Howdy everybody, this is Joe and welcome to 10 Minute Tech. This is the second lesson in our series on what is an Azure Virtual Network. Now before we go any further, let's talk about the Azure Classic Portal versus the Azure Resource Manager. I'm not going to go into a lot of detail here, just know that everything in this series that we do is going to be using the Azure Resource Manager and not the classic Azure Portal. There's a difference between the two, but again, I'm not going to get into a lot of detail on that right now. So we're going to use these diagrams as examples of traffic that is requested and how it goes through the various network and computing components in each type of Azure network. So in this network you can see this is an Azure Virtual Network and it is isolated and it is its own standalone network. There are no other components that it connects to, whether that would be another Azure network or whether it be something on premise. In this instance, everything is housed in this one virtual network, which you can see down here at the bottom. The network is made up of two subnets, a front-end subnet and a back-end subnet, and those sound and are exactly as you would think they would be. This subnet has been configured to allow access to and from the internet, while this subnet is not. It's only allowing access from things within the virtual network itself. There is no external connectivity to any of these systems. So let's say that we got somebody on the internet and they're going to make an HTTP port 80 request to a web server. The first thing that would happen is that it would come into the virtual network, and before it hits the load balancer, it goes here to the network security group. You can consider this network security group a lot like a firewall. Actually, it is exactly like a firewall. It has a series of rules and roles, and those rules are listed in a certain amount of priority, and every request from traffic that comes into the NSG is evaluated based on those rules. If it passes those rules, it will send the traffic to the next hop, which is the load balancer. If it doesn't pass the rules, then it will drop the connection. Now in this instance, port 80 HTTP is allowed through the NSG, so it will allow that traffic to pass to the load balancer. The load balancer then gets the packet, or then gets the request. It will pass it to the first available web server as part of its load balancing availability set. So in this instance, let's say it would go here, it'll go right to here, and then this web server will start processing the request, and as it does it, it realizes that it needs to be able to get data from the back end subnet, which they're in something from a database. So it will send it to the next hop. Before it does get to the next load balancer, it will have to go through another NSG, and that NSG is going to run its rules against it to validate whether or not traffic is allowed to be passed through to the load balancer. So in this instance, we could have an NSG set up to say that only machines with this IP address from this server and the IP address from this server are allowed to pass through and talk to this back-end system. If you remember in our previous lesson, we spoke about IP address assignment and whether they were static or dynamic. Dynamic means that the IP address can change, especially when the machine is rebooted, and static means the IP address will never change even if it has been rebooted. In this instance, you would want these web servers to have static IP addresses because you would have those as rules. Those IP addresses would be used as rules in your network security group, and that rule would say that these IP addresses are allowed to talk to this load balancer. Anybody else or any other device that doesn't have those IP addresses or not included in this NSG would be rejected. So in this instance, our NSG says you can only communicate if you're with these two web server IP addresses, so you would want those to be permanent and not changing. So it passes that rule and it gets passed back to the back-end load balancer. Now we've got a couple different types of servers here on the back end, right? We have a domain controller, we have two database servers. Now the load balancer is going to have to first figure out what type of request it is, where it's bound, and what type of service it needs to connect to. So the load balancer will evaluate the call and realize that it needs to talk to a database server and not a domain controller. So it will send the request to the first available database server. When it does, the database server will validate and execute the request, and then the traffic basically goes back out the same way it came in. It goes through this load balancer, through the NSGs, through the web server, back to the load balancer, through the NSG, and finally back to the requester. So this has been an overview of the Azure Virtual Network. And again, this is a standalone. Everything is in Azure itself. All of these components are, and they would all be managed through the Azure portal or through PowerShell. Our next example is Azure VNet to Azure VNet. Now, this is a very handy thing to have because you can have different Azure virtual networks in different regions or even in different subscriptions in different regions, and you can connect them together. So in this instance, basically we've recreated what we already have. In this instance, we have a front end and a back end subnet in one virtual network, except that this Azure instance is in the East US region. We also have over here an instance that's about the same thing in the West region. Now, they don't have to match identically. This is just for my interpretation, for my examples for our lecture today, but in this instance they happen to. So what you need to do is you need to connect these two, and to do that you use VPN gateways, and these are services or software solutions that are available in the Azure marketplace, and there are a lot of different ones that you can select from, but essentially you're going to enable this service for a VPN gateway on both ends. You're going to configure those services so that they can connect to each other, and then they're going to spin up an IPsec tunnel across the internet, right, so that they can be connected. Our final example is a hybrid network, and this is essentially taking an Azure virtual network and connecting it to an on-premise network or your on-premise data center. This is a pretty popular option right now, as there's a lot of data that's going to have to reside in a legacy data center, and that can be through regulatory reasons, or perhaps there's an application that's not going to be able to be adapted well to a cloud environment. Regardless, you're probably always going to have some kind of connectivity between these two environments. So in this instance, what happens is that you, just as before in the VNet to VNet, you get a VPN gateway service here, and then you get most likely a physical appliance, a VPN gateway appliance on your on-premise network. Make sure they're compatible, and then you configure them, and it spins up an IPsec tunnel between the two. So I know I promised that this would be kind of like diagrams only. Sorry that I misled you there. I didn't mean to, but I wanted to make sure that I focused a little bit more on the type of Azure virtual connections or virtual network connections. So first you have site-to-site, which is a VPN connection over IPsec, and this type of connection requires a VPN device or an RAS. Then you have point-to-site, and VPN connections are over STP or Secure Socket Tunneling Protocol or V2.0, and this connection does not require a VPN service. Then you have, as we talked earlier, a VNet to VNet, right, which is a type of connection that uses the site-to-site connection. The VNet to VNet is a VPN connection over IPsec, and it does not require a VPN device. Then you have multi-site. This is a variation of site-to-site configuration, and allows you to connect multiple on-premise sites to a virtual network. And finally, you have express routes. So in the previous example, and I'll go back here, what we did here is we set up a VPN gateway between these two, and that may not be enough. There may be some real connectivity or some real data that you need to get back and forth here, and that you probably need to be able to have it pretty standardized, right? You're going to want to know what your bandwidth is and how much data you can put across there. The VPN circuit, the VPN or site-to-site in this manner, does not provide you with a lot of guarantee for latency. If you want that, then you're going to want to come back here and you're going to want to take a look at ExpressRoute. An ExpressRoute is a direct connection to Azure from your WAN and not a VPN connection over the over the public internet. So what this means is that you're going to work with one of your networking partners, and you're going to set up a circuit between the two and work with Microsoft, and they'll help you get that set up. So this brings an end to this lesson in Azure Virtual Networks. I thank you for listening, and I hope it was informative for you. In our next lecture, we're actually going to go through and start seeing some real-world examples and some configurations of these options. So thanks for hanging in there during these kind of two lessons that are very lecture-heavy. Next, we're going to get into the meat of this and see all of these Azure Network components in action. Thanks again. Don't forget to subscribe and like my video.